All right, guys, I'll get started. All right, so first things first, the review for the test. If you go to the home page and if you go to the page, on the home page right here, you'll see right here you have final exam review. And then from here, you can find the documents that will be working on today. Hello, Miss Clarissa.
Good morning. How are you?
Doing just fine.
I have a question. Do these count like the recitations? Do they count for our math lab hours?
Yes, ma'am. But
Okay.
you do need to stay, but they do count, yeah.
Okay.
All right. Send me a message with your student number. Okay.
For the hours?
Yes.
Okay.
Yeah, I gotta take attendance. Today is December 1st. Wow. All right. All right, but anyways, today I am going through the review for the final exam. So feel free to ask questions as I go along. Right, so here is our document. As with most things, most tests, the most important thing is to actually just read the questions carefully. Ms. Michaela, can you send me your student number in a message, please? Thank you. All right. Question number one. I'm not going to do every question. Many of the questions are basically the same kind of question. And also, we'll get through as many as we can, many different types of questions as we can. But again, what I'm saying is just feel free to ask any questions because, basically you're representing everybody else who's out there and they may want to ask questions. All right, so list the intercepts of the graph. This is the x-axis. So these are the two x-intercepts. And so that's going to be 1, 0. And then the other intercept is going to be -1, 0. And those are your x-intercepts. This graph does not have any y-intercepts. Again, remember the final exam is going to be multiple choice. So you have to always use that to your advantage whenever possible. All right. List number 2, list the intercepts for this graph right here. To find the x-intercepts, remember you have to make y equals 0. So that's going to be x squared plus 0 minus 16. Take the 16 over, x squared equals 16. And then you take the square root on both sides. The thing you have to remember is that a square root produces 2 answers. The square root of 16 is plus or minus 4. And so you have 2 x-intercepts. Questions there? Now the y-intercepts are the reverse of the x-intercepts. And like I always say, to find the y-intercept, what you simply have to do is set the other letter equal to 0. So the y-intercept is going to be x equals 0. So plug in x equals 0. 0 squared plus y minus 16 equals 0. Y minus 16 equals 0. You take the 16 over, y equals 16. And so the coordinates for the y-intercept is going to be 0, 16. Questions there? Mhm. Question number 3. Again, this is being recorded. I will post the recording as well. Excuse me. Okay, find the equation for the line, the given properties right here, and they want it in slope-intercept form. So you find m first, which has formula y2 minus y1 over x2 minus x1. Y2, that's -1 minus -7. X2, that is 6 minus -8. -1 plus 7 over 6 plus 8. Oof. That's going to be 6 over 14. It's going to be 3 over 7. So your average rise over run is 3 over 7. So that's your slope. And then what you do is you take that and you either plug it into the slope-intercept form, or you plug it into the point-slope form. If you plug it into the point-slope form using this point, it'll be y minus -7 is equals to 3 over 7 times x minus -8. If you plug into the point-slope form, it's going to be y equals mx plus b. Y is -7 is equals to 3 over 7 times x -8 plus b. And either way, they will both work towards give you the same solution for b.
So
Mhm.
when you're plugging in the x and the y, you use, it doesn't matter which set you use. Do you use the next one or?
That is correct. It doesn't matter which points you use.
Okay.
You'll get the same answers. All right, so let's go ahead and find b. Make this 8 over 1. That's -7. 3 times 8 is 24 negative. 7 times 1 is 7 plus b. I'm going to multiply both sides by 7. And so I'm working with the fractions. I'm just going to get rid of the fractions altogether. So you multiply by 7. And then you multiply over here by 7. I'm out of space. I'm going to do it right here. That's going to be -49. 7s will cancel. Equals 24 plus 7b. Subtract 24. That's 6 plus 1 more. So that's going to be -73 equals 7b. And then you divide by 7. B is -73 over 7. Double checking my math. Make sure I'm good. Oh, I did make a mistake. This was a -8, so it should be a -24. But that should be a -24. Means I need to add 24. It's one of those key things that you have to learn how to do on a test is to be careful. So 49 minus 24, that's 25. And so B is -25 over 7. Y equals 3 over 7 x minus 25 over 7. Questions there?
So the slope intercept form would be y equals 3 over 7x minus 25.
Over 7.
Okay.
Yeah, the nice thing is that because it's going to be multiple choice, you automatically know which option they're looking for. If it's going to be this one or this one, because all the options, would be in a form that you'd recognize. Okay. Anybody else? All right, complete the graph so it's symmetric to the y-axis. I will highlight the y-axis. The y-axis is this axis right here. So the second half of the graph must be over here. And now the y-axis is halfway through the graph, and that will be the graph being symmetric about the y-axis. If instead it said they wanted symmetric about the x-axis, then again, highlight the x-axis, right? So, and so this point will come down here. And so the graph will look like this. And so now this graph right here is symmetric about the x-axis. Questions there? If they asked for the graph to be symmetric about the origin, that one's a little bit tricky, but the origin is the single point. Ms. Jasmine, go ahead and send me your student number in the chat, please. If they want to about the origin, well, that's a little bit tricky. What you have to do is you have to reflect the graph in both axes. So if I take the graph right here and then I reflect it in the y-axis, I get this right here. And then I need to take this answer that I just got right here and then reflect that in the x-axis. And so this point up here comes down here. Let's switch colors. The point comes down here. And so the graph goes like this. And so if I erase the red line, and just have the blue line only, now this is symmetric about the origin.
Can you repeat one more time?
All right. So there was, because reflection in the origin is a little bit tricky because the origin is a single point. The way you do it physically is you do two reflections. You reflect it first in the x-axis and then the y, or vice versa. It doesn't matter which order you do it in. So I reflect it first in the y-axis. So I get this piece right here. So if you look carefully, the graph in red is symmetric about the y-axis. And then I take the red graph that I have and I flip it over the x-axis. And so, for example, this point up here is going to end up down here, while this point down here is going to end up here, right? And so that will leave me with starting down here, going this way. And so now if I remove the red graph, and now I just have the blue. Now I just have the blue. This graph is symmetric about the origin.
So whichever, so say like I reflected it in respect to the x-axis, whatever axis are like reflected in, I would just do the opposite. Yes. For okay.
Yeah, basically you have to do them both, but one at a time. Okay, it doesn't matter which one you do first, you get the same graph. Ms. Jenkins, send me a student number in a private message, please. Okay, let's try number 7. Okay, find the equation of the line with the given properties. It is perpendicular to this line right here and has a y-intercept of -4. So the line we're looking for is y is equals to mx plus b. And since they tell us the y-intercept is -4, we know that the line is going to be y equals to mx minus 4. So all that remains is that we need to find m. Well, my equation is 5x plus 6y is equals to -5. And what I'm going to do is I'm going to put this in slope-intercept form. Take the 5x over. So 6y is equal to -5x minus 5. You guys remember that rule? If you take something and you drag it over to the other side, its sign is going to change. It's just going to be doing the opposite when it is on the opposite side of the equal sign. And then I divide by 6. The y is equal to -5 over 6x minus 5 over 6. What that tells me is that the slope of this line right here is -5 over 6. And if the slope of this line, which is perpendicular, is 5 over 6, then the slope of the line we're actually looking for is going to be the opposite reciprocal. It's going to have an opposite sign. So instead of being negative, it's going to be positive, and it's going to be the reciprocal. And so the slope for your perpendicular line is going to be 6 over 5. If the lines were parallel, then the slopes would be the same. And so the final answer is y is equals to 5 over 6x minus 4. Questions there?
I got a little lost.
All right.
Well,
So
wait, before you further explain, you meant it's supposed to be 6 over 5 because
yes, ma'am.
Yeah.
Yeah, because this is the right slope. Yes, 6 over 5.
Okay.
Thank you. Was that your problem, Miss? Was that the problem? Why you got lost, or was it something else?
You said we're supposed to find an equation.
Yes, ma'am.
For the line. So the equation would be 6 over 5.
The equation is up here.
Oh, you put it in. Okay.
But did that answer your question now? Yes.
I'm trying to like look at it to make sure I understand it.
So the first thing that I did was I used the Y-intercept. That gave me the -4.
Okay.
This question right here, as it's written, I do not know what the slope is. And so what I had to do was I had to transform it. I had to solve for y. So I took the 5x over, it became -5x. And then I divided by 6 to cancel out the number in front of y. And so that leaves me with -5 over 6x.
And that was the slope.
Yes.
For the first line, and then you flipped it to get or you got the reciprocal to get the slope for the perpendicular line.
Almost. You have to do two things. You have to get the reciprocal, and then you have to change the sign.
Okay.
All right. So see, this one over here is negative. This one over here is going to be positive.
Okay. So in order to get the slope of the equation, you just have to solve it for a y. Okay.
Because once it's in slope-intercept form, you can read the slope.
Okay, I think I'm confused because what happened to the x? Like, did you plug something in there to get rid of it, or?
No, I did not. You just have to remember that the slope is the number in front of x.
Okay. Oh, because that's the mx. Okay. Okay, I got it.
All right. Anybody else? Okay. Clear. Buzz. All right. Write the equation of the circle in standard form. you have to memorize the formula for the circle. The formula is x minus h raised to the second power plus y minus k raised to the second power is equals to the radius squared. And once you have it memorized, you just plug in for h, k, and r. So the answer is going to be x minus h is 2, y minus k 7. Don't forget the squares, and that's equals to 12 squared. Normally, they don't leave the 12 squared in there, but because it's a multiple choice exam, you have to just look carefully. Normally, they write it as 144 because, 12 squared is 144. But there is a small chance they will have the 12 squared in there instead of the 144. Of course, they're equivalent. So you just have to look carefully at your options. Questions there? Okay. But yeah, this question is all about whether or not you remember the formula or not. Number 9. Plug in a binomial into a function. They want us to find f of x minus 1. And what I like to do is I like to kind of remind ourselves. If I ask you to find f of 100, this would simply mean 2 times 100 squared plus 2 times 100 plus 2, right? You're plugging in 100, so everywhere you see x, you replace it with 100. So if I ask you to find f of x minus 1, well, that's going to be 2 times x minus 1 squared plus 2 times x minus 1 plus 2. The only other part that is tricky is that you have to remember that x minus 1 squared requires a little bit of work. If you take any binomial and you raise it to the second power, you have to do this process right here. You have to write it as the binomial multiplied by itself. That's what squaring means. And then you got to follow that. Take the first term and multiply it by the other first term. Take the first term and multiply it by the last term, -1. Take the second term and multiply it by this one, the inner term. Oh, so it should be 1x minus 1x, and then multiply the last terms together. Plus 1. The two middle terms will always combine and then double. And so x minus 1 squared is actually x squared minus 2x plus 1. And we can actually verify that. If I had 5 minus 1 squared, that's going to be 4 squared, that's going to be 16, correct? If I plug in 5 into this equation, 5 squared minus 2 times 5 plus 1, that's 25 minus 10 plus 1. I get the correct answer of 16. Right? And so we're not just foiling it out because we feel like it. Anything else will take us in the wrong direction. But anywho, now that I have this becomes 2 times x squared minus 2x plus 1 plus 2x minus 1 plus 2. Again, remember this thing is being recorded. So when you're going back and looking at the recording, you can always pause and rewind, to go back over stuff if you need to. Distributing the 2, that's 2x squared minus 4x plus 2 plus 2x minus 2 plus 2. Now, after I finish multiplying, I can do my addition and subtraction. So I'm going to group on like terms. 2x squared, there are no like terms here. These two are like terms. And -4 plus 2 gives me -2x. And then these three are like terms. 1, 2, 3. And then all of that combines give me 2. 2 minus 2 is 0. 0 plus 2 is 4. 0 plus 2 is 2. And so after all of that hard work, it breaks down to this equation right here. Questions there? Comments? Oh, wait a minute. I made a mistake. Stop making mistakes, please. There should be a minus sign. Let's see.
Even though it's not a minus, I think we still get the point of what you're trying to explain.
I know, but I still gotta fix it. I do. So this is gonna be minus. That's gonna be minus 2. That's going to be minus 2x plus 2. And so then the negative 4 and the 2 will combine, give us the negative 6. And then I have 2, I have negative 2. I have 2, I have 2, and I have 2. So 2, I have 2, and I have 2. So that combines, give us 6. There we go. Oof. Again, what happened was I looked at the original problem and I got the same answer. And I said, that doesn't make sense. To get the original answer, that means that nothing changed. And so, that kind of tipped me off that something was wrong. And so with that in mind, I went back and I double checked my signs, which normally is where the mistakes are made. All right. Number 11 is next. Find the domain of the function. To find the domain of a fraction, you have to set the denominator not equal to 0. The reason is we cannot divide by 0. And so the denominator should never equal 0. X squared minus 81 factors into x plus 9, x minus 9. We call that a difference of squares. And then if we have that difference of squares, we set each one not equal to 0. X plus 9 cannot be 0. Therefore, x cannot be negative 9. And then x minus 9 cannot be 0. Therefore, x cannot be positive. This is the answer in set builder notation. The reason why we set the equation up this way is that it'll automatically give us the set builder notation answer. Graphically, again, it's multiple choice, so I have to cover all my bases. Negative 9 and 9. You will have an open circle at each of these. Remember, an open circle means no solution or not equal to, and then you shade everywhere else. And then the last one is interval notation. The first interval represents negative infinity to negative 9, union. The second interval represents negative 9 to 9. And then the third interval represents 9 to infinity. I always recommend that you, until you really get good at this, graph it on a number line first, because once you graph it on a number line, it's pretty easy to pick out the intervals. Questions there? All right. I'll do number 12 as well. For number 12, the rule is slightly different. The rule is for a radical, you have to set the denominator. No, denominator. You have to set what's underneath the radical greater than or equal to 0. But this is also a fraction, and so you have to set it not equal to 0. And when you combine these two statements together, you simply get this greater than 0. The not equal cancels out equal. And so you simply take the x minus 10 and say it must be positive. And that covers both bases. I won't end up dividing by 0, and I won't end up taking the square root of a negative number. Add 10. And so therefore x is greater than 10. That automatically is your set builder notation. Number line. Somewhere along this number line is number 10. And then that's going to be an open circle. That's going to be an open circle. And I shade the side greater than, numbers greater than 10. So you shade going upwards, right? Greater than. I only have one interval. And so interval notation is going to be 10 to infinity. Questions there? If you remember the basic rule for interval notation, if you see an open circle cut in half gives you 2 parentheses. And that's why we use parentheses to represent open circles. The two things are equivalent. All right, you use a square bracket when you have less than or equal to. Questions there? All right, cool. All right, I have the graph of the graph right here of a function. They want us to tell me, is it odd, is it even, or is it neither? Well, there are several ways you can decide if the graph is odd, even, or neither. The first way is to remember that even functions are symmetrical about the y-axis, while odd functions are symmetrical about the origin. The odd starts with letter O, origin starts with letter Y. The x-axis doesn't play a role here. We only have two options, odd or even. And so what that means is that when you go look at the graph and ask, is the y-axis going down the center? And is the graph symmetrical about the origin? Well, clearly it's not even, because it's not symmetric about the y-axis. But the odd one's a little bit harder. And so we got to go through that same process that we did the last time. You take half the graph, and then you reflect it across the y-axis first. Or it doesn't matter which axis, you just got to reflect it across one axis. And then you take that answer, and you reflect that answer across the other axis. In this case right here, the x-axis. And you can see that gives us perfectly the other half of the graph. I don't need this anymore. Green dots, I don't need them anymore. And so therefore this graph is symmetrical about the origin. Therefore, the graph is odd. If I had a graph that looks like this would be even. And basically any other graph would be neither. If I had a graph that looks like this, or if I had a graph that looks like this, or if I had a graph that looks like all three of these are neither. Questions there? Okay. Number 16, determine whether the graph is even, odd, uneven. There are two ways to go about this. Right here is to plug in negative and negative x. If you get the negative version of the function, then the graph is odd. If you get the original function back, then the graph is even. The other way to do this is you remember the rules: an odd function divided by an even function is odd, and an odd divided by an odd is even, and an even divided by an even is even. Right? If you remember those rules, either way, they will take you to the answer. Now, if you look up here, you can see this is x cubed, so you can see this is an odd function. And in the denominator, you see x squared and the number 5. And so that's going to be an even function. And you might be thinking, wait, how is that even? I see the number 5 right here. You have to remember the rule for evenicity and oddicity is that a number by itself is always considered to be even. A number by itself technically is 5x to the 0. Remember, we judge if a function is even or odd by the power of x. And so a number by itself is actually even. So my numerator is odd. My denominator is even. And odd divided by an even is odd. So this function is odd. Questions there? I can further verify that by plugging in negative f of x. That's going to be negative x to the 3rd divided by 7 times negative x squared plus 5. That's going to be negative x cubed divided by 7x squared plus 5. And of course, the negatives cancel. And so this right here is the negative version of the original problem. This is negative f of x. And if you recall, the minus sign moves from inside to outside. It means it is an odd function. Questions there? Find the average rate of change for the function. That simply means find the slope. So I create a little table of values. They say from 3 to 5. So x is 3 and x is 5. To find the y value, I plug in 3. That is 9 plus 9, so that's 18. To find the other y value, I plug in 5. 5 squared plus 3 times 5, that's 25 plus 15, that's 40. And now I have enough information to find the slope. Again, remember, average rate of change is literally just asking you to find the slope. I think I can squeeze it in over here. Don't you think? Don't you think? Squeeze in. I'm squeezed in the middle. Smack dab in the middle. Y2 minus y1 over x2 minus x1. 14 minus 18 is 22. 5 minus 3 is 2. The average rate of change is going to be 11. Questions there? Comments? Queries? Concerns? All right, cool. Okay, number 19, graph the function by starting with the graph of the original function and then using the shifts, compressing and reflecting to get the graph of the new function. Well, this is squared right here. So the graph of the old function is x squared graph. Looks something like this. The x plus 7 tells me the graph is going 7 units to the left. So 7 units this way. And then the plus 4 on the outside tells me the graph is going to go up 4 units. And so that's going to go this way. Again, remember that when you're on the inside, you do the opposite. So you see x plus 7, you actually do the opposite of plus 7, you actually go minus 7. And then when you're on the outside, you find you just go ahead and increase by 4. So -7 is going to be right here. 5, 6, 7. And then we're going to go up 4. 1, 2, 3, 4. The graph is not upside down. And so I'm going to have exactly the same graph. It's just that it has been moved over 7 units and then moved up 4 units.
How do you know that it's moving to the left again?
The number on the inside right here, you do the opposite to what you see.
On the inside of the parentheses.
Mm-hmm.
Then if
Yes.
it was outside of the parentheses.
And you do exactly what you see. Let me demonstrate that for you. Can you see the GeoGebra that I have on here?
Yes.
If I take the equation y, let's go f of x, sorry. That's better, I think. Equals x squared. That's this lovely graph right here. Now I gotta right click on, I got to settings, I got to unclick fix object. Okay, I'm ready to go. Now, if I take this object right here and I move it to the right, see, now it's moved over 1 unit. Look at the equation right here. It's going to be -1. Now, look at the equation. I'm going to keep moving it to the right. Look at the equation as I'm moving it. It's right here. So I'm moving it. Look at the equation. Now I get to 2, -2. If I move it over 3, it's going to be x -3. Right. So when I'm moving it to the right, I'm actually seeing the opposite number. Although I see a 3 right here, I'm seeing a -3 right here. Now, if I was to move it in the opposite direction to the left, notice right here, now I'm seeing plus signs. And so that's just the thing, is that when you are moving left and right, you're actually doing the opposite to the sign that you see. So although you see a +3 right here, the graph is actually at -3. Now, if I was to move it up from this point right here, notice right here that the +3 is staying. What's changing is the number on the outside. And so the number on the outside is what's telling us if I'm moving up or down. And notice, unlike in the previous case, it's doing exactly what it's supposed to do. I moved up to 2, +2. I see a +2 here. If I was moving down to -3, I would see a -3 right here. Okay?
Got it.
And so we can predict, if I were to look at this point right here, see, this is 4, so it's going to be x -4 squared, and then here will be +2. So if I move the graph to that point right here, it'll be x -4 +2. There we go. And so it ends up exactly as we want to be. If you put a minus sign in front of the equation, it'll make the graph upside down. You'll notice the same rules hold. 4 plus 2. See the negative 4 and the plus 2. The minus sign in front just makes the graph upside down. All right. If you change the number in front, let me put it back to regular. If I put the number in front, if I made it a 2, the graph will just be skinnier. It's because it's been pulled upwards. As I make this number bigger, you can see it just gets pulled up more and more. Cool. And so we call this a vertical stretch. Because the graph is kind of like a rubber band. You have your finger right here in your rubber band, you're pulling. The more you pull, the sharper the rubber band is going to be. Of course, if I put a minus sign in front of all of this, it's just going to flip it upside down. All right.
So what would you said, so that would that be compressing it or stretching?
When the number is greater than 1, we call it a stretch. When the number is a fraction, we call it a compression.
If it's a compression that's making it wider.
Yes. So right here, if I was to put in a fraction, for example, 1/2, it'll get wider. If I made it 1/3, it'll get even wider. If I would make it 1/4, it'll get wider. So this time, like, you're squeezing your rubber band down, or you're not, you're not putting any stretching on it. And so what happens, it gets wider. All right. And of course, if I put a minus sign in front of it, it's just going to cause it to flip. The nice thing right here is that these rules hold for any kind of function whatsoever. If I had an x cubed function instead, like so, if I will move it over to 3 and move it up 2, you know exactly what the function equation is going to be. If I move it over to 3, it's going to be a -3. And move it up 2, you're going to have a +2 on the outside. All right. Put a minus sign in there, it'll just flip it upside down. Of course, though, you do need to memorize what all your basic graphs look like. Because without them, it's kind of hard. You're kind of lost in the weeds. But that's what it's all about. Selecting the graph. Questions there? So for example, this graph right here, it's going to be -4 and -3, and it's going to look like a V. The absolute value function looks like this. And so the -4, 1, 2, 3, 4, and then -3, 1, 2, 3, is going to be a V right here. Uh-oh, I missed it. All right. Sometimes they ask these questions in word form. Find the function that is finally graphed after you took this graph right here, it's shifted to the right 3 units, stretched by a factor of 3, and shifted down by 2 units, and then reflected across the x-axis. And so this right here is, let's do it step by step. Shifted to the right 3, so that's going to be y equals absolute value of x -3, and then stretched by a factor of 3, so y equals 3x -3, and then shifted vertically down 2 units, x minus 3 minus 2, and then reflected across the x-axis, you make that negative. Question there. Excuse me.
So to reflect it, you square it or?
Oh, minus sign in front.
Oh, okay.
Reflect across. Remember, we made the graph upside down, put a minus sign in front of the graph.
So it wouldn't be possible to flip it across the y-axis.
To flip it across the y-axis, you put a minus front sign in front of the x. So this will flip the graph over the y-axis. Okay. Anybody else? All right. All right, define the zeros of a linear function. The zero means to find the x-intercept. They mean the same thing. So that means you guys set equal to 0. For some reason, a lot of people, when they hear find the 0, they plug in 0. But no, that's not what they want you to do. Add 7. 7 equals negative 1 over 3x multiplied by 3. 21 is equals to negative x divided by negative 1. X equals negative 21. We call negative 21 the 0 because if I plug negative 21 into this equation, my answer is going to be 0.
So you don't plug in 0 for x, you make g of x 0 and then for x.
That is correct. Yeah, the 0 is finding the same as finding the x-intercept. All right. Number 28, Marty's Tees and Jackets Company is to produce a new line of jackets with embroidery of a Great Pyrenees dove on the front. The fixed costs are $580. The fixed cost is going to be your Y-intercept. It's a production, and the variable cost is $39. The variable cost is your slope per jacket. Again, the per right here is the hint that's telling you that it's the slope, because the slope is your change per unit x. Write the equation. 39x plus 580. Questions there? All right. All right, factor to find the zeros of the quadratic equation. I'll put it over here so I have more space. 4x squared minus 5x minus 9. Let me show you two ways to factor. One way is what we call the guess and check method. And so this is 4x squared. So I'm going to put 2x and 2x because 2x multiplied by 2x is 4x squared. And then that's negative 9. So I'm going to put a negative 3 and a plus 3 right here because when I multiply those together, I also get negative 9. And then I'm just going to see if this works. 4x squared plus 6x minus 6x plus 9, and oh no, this gives us negative 12. No, so it should be a plus 6. That gives us 0. Yeah, that's not right, because I need to get a 5x right here. And so what I'm going to do is I'm going to go back, and I'm just going to try again, but with a different set of values, and see what happens. The point right here is you just gotta keep trying until you get a pair of numbers that work. Hopefully this thing factors. I have no idea what the answer is. So I can leave the 2 and plus 2, but I can go negative 9 and positive 1. Again, those two numbers multiplied with this 9. 2 times 1 is 2x. Oh, 2 times 2 is going to be 4x squared. 9 times 2 is negative 9x. 9 times 1 is negative 9. Ah, that doesn't work. That gives us negative 7. Oh, man. Again, the point is I am guessing and then I'm checking. All right, so let's put a 4x here and a 1x over here. And let's put a negative 3 and a positive 3. 4x squared plus 12x minus 3x minus 9. That doesn't work either. Is this thing factorable? Use factoring, they say, yeah. Okay, I'm getting like everybody else. Oh no, it's not working. Oh, maybe that would work. Oh, I think I got it. Again, so that didn't work, so I gotta try again. Again, the whole process right here is guessing. So I'm going to leave the 4x, and now I'm going to use negative 9 and positive 1. Again, because those multiply to give me negative 9. 4 times x, 4x squared. 4 times 1 is plus 4x. 9 times x is going to be negative 9x. 9 times 1, negative 9. And those combine to give me the right middle term. And so therefore, that is the correct factoring. A different way that I like to factor is called the modified AC method. And so what you do is you create a little diamond. And the top of the diamond, you put the answer to A times C. So 4 times negative 9 is negative 36. And you put B in the down here, negative 5. Now what I need are two numbers that when I multiply them, I get negative 36. And when I add them, I get negative 5. What two numbers? Multiply negative, add negative 5. I don't know. 4 and 9? Yeah, there you go. Negative 9 and positive 4. And so what happens right here is parentheses, 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 parentheses. You enter the negative 9 and you enter the positive 4. And what happens is you simply take the 4x squared and split it up. I'm going to put a 4x here and a 1x. Technically, it does not matter how you split out the 4x. The only requirement is that the two things multiplied together must give us 4x squared, must give us the first term. All right. Now, if you were to look at this very carefully, you'll notice that there's one major problem, right? 9 times 4 is 36. The last term right here is 9, right? And so that's why it's called a modified AC method, is that you now have to modify this to get it to the right answer. This is too large. The number in front of x right here, you divide it into the other factor. And the number in front of x right here, you divide that into the constant on the other factor. That leaves us with 4x minus 9, and then x plus 1. And this would be the factored form of our equation. Again, it's the same answer. It's just a different way of getting there. Questions? Now the question said to then find the zeros. So I gotta set this equal to 0. For x minus 9 equals 0. X equals 9/4. X plus 1 equals 0. X equals -1. Okay. Subtract 1 on both sides. Add 9 and then divide by 4. Questions then? All right, next one, find the zeros by completing the square. You take your equation, x squared minus 12x plus 32, and you set that equal to 0. You take the 32 across, you take the constant term across, x squared minus 12x plus, leave a space, is going to be equal to -32. You got to subtract 32 from both sides. And then you have to fill in the missing term to complete the square. The formula is b divided by 2 squared. So in this case, b is -12. That's -12 divided by 2 squared. And that's going to be -6 squared. It's going to be 36. And so you insert 36 to complete the square. You put a plus 36 here. And because there's an equal sign, I have to put a plus 36 here as well. Questions there? You must remember that formula, b divided by 2 squared. I need some space. This side factors is going to be x minus 6 squared. The other side right here is going to be +4. X minus sign and the square root of this, x minus 6 squared. Another way to do it right here is just divide this by 2. -12 divided by 2 is -6. Or you could factor it along, but you don't have to. Take the square root, x minus 6 equals +or-2. X is equal to 6 +or-2. 6 plus 2 is 8. 6 minus 2 is 4. And so those would be your zeros by completing the square. Questions there? All right, to find the real zeros by the quadratic formula, x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. A is 5, b is -18, and c is -8. So x is equals to -b plus or minus, not -b. Oh, sorry. X is equals to -18. Plus or minus the square root of -18 squared minus 4 times 5 times -8 all over 2 times 5. That's 18 plus or minus the square root of 18 squared, which is 324, minus 4 times 8 is 32. 32 times 5 is 160 plus 60. And so that's going to be 18 plus or minus the square root of 484. I've seen that number before. Over 10. Isn't the square root of 484 24? I believe it is 24 times 24. I know my 24 times. No, it's 5, 6. Break this number down. 484 divided by 4 is 121. Oh, and 121 is 11 squared. So 484 is equals to 11 squared times 2 squared. If I'm taking the square root of this is just going to be 11 times 2. So it's going to be 22. Oh, 22 times 22 is 482. Oh, okay. That's 18 plus or minus 22 over 10. 18 plus 22 is 40 over 10. That's 4. 18 minus 22 is negative 4 over 10, negative 2/5. And those will be my zeros from the quadratic formula. Question there? Whew. I need some oxygen. Questions there? All right, cool. To find points of intersections, you simply set the two equations equal to each other and then solve the resulting quadratic equation. I'm not going to do it. I'm just going to set it up. Subtract x squared, add 12x. What might not be the bad? And subtract 27. Cancel, cancel, cancel. That's x squared plus 0 minus 9. Oh, that's going to be easy. And so therefore, x squared minus 9 equals 0. X squared equals 9. X equals plus or minus 3. And so, to find my points of intersection, I know x equals negative 3 and 3. And so what I got to do is I got to take those and plug them into the equation. It doesn't matter which equation you plug it into. It'll give you the same answer. So you just got to plug it in. I'll plug it into this one. It looks like it has small numbers. So you plug in negative 3. Negative 3 squared minus 12 times negative 3 plus 27. Sheesh, I thought I just had small numbers. That's 9 plus 36 plus 27. 9 and 27 is 36. 36 plus 36 is 72. And then I have to do it again for the other points. This time, I have to plug in positive 3. That's 3 squared minus 12 times 3 plus 27. 9 minus 36 plus 27. That's 0. 9 minus 9 minus 36. Yeah, it's fine. Yeah, it is 0. That's what it's going to be. And so those right there are your two x-intercepts. Questions there? All right, cool. Number 37, using its vertex axis of symmetry and intercepts. Graph this function right here by first finding these three things right here. All right, let's start with the axis of symmetry. The axis of symmetry is x is equal to negative b over 2a. And so that's going to be negative 12 over 2 times 1. So the axis of symmetry is at negative 6. The vertex follows by axis of symmetry, the vertex x comma y. The x coordinate is always the axis of symmetry. That's why you find axis of symmetry first. So that's f of negative 6. That's going to be negative 6 squared plus 12 times negative 6 plus 36. That's going to be 36 minus 72 plus 36. That's 0. Oh, wow. And so the vertex is right here at 0. And then your intercepts. I've already found the x-intercept since this y equals 0. That's the only x-intercept there is. There's no need for me to set it equal to 0 and factor and solve. I already know what's going to happen. I guess I can still do it. This is x plus 6, x plus 6. Therefore, x plus 6 equals 0. Therefore, x equals negative 6. That's the x-intercept. But again, I already knew that. And the last one is the y-intercept. Make x 0. That's going to be f of 0, 0 squared, plus 12 times 0, plus 36. This is going by 5, 10, 15, 20, 25, 10, 15, 20, no. So going by 4s. 4, 8, 12, 16, 28, going by 4s. 24, 28, 32, 36. So the y-intercept is going to be right here. And so that's the graph of the function using the vertex, the axis of symmetry, and the intercepts. Questions there? That's a lot of work. The axis of symmetry, x equals negative b over 2a. The vertex, you take that answer and you plug it in for x. The x-intercepts, you set it equal to 0, factor and solve. The y-intercept, you plug in 0 for x. The y-intercept is going to be the number by itself right here. Because these two will vanish when you plug in 0. All right, determine where the function is increasing and where it's decreasing. It is a quadratic function. So that all that's really required is that we find the axis of symmetry. Because the axis of symmetry will split the graph into an increasing side and a decreasing side. So that's going to be x is equal to negative b over 2a. That's going to be negative 12 over 2. That's going to be negative 6. So somewhere along my number line is the value of negative 6. And Because the graph is positive, the graph is going to open upwards. So the graph will decrease on this side, and it will increase on this side. If the graph was negative, it'll open downwards, and the increasing and decreasing sides will flip. So if I was to shade this on a number line, open circle, this is the decreasing side. So where's the function decreasing? It's decreasing from negative infinity to negative 6. Where is it increasing? Increasing is shading the other side. The graph is increasing from negative 6 to positive infinity. Again, to tell the graph is increasing or decreasing, I only need to identify the axis of symmetry, because the axis of symmetry splits the graph into two halves. One side increasing, one side decreasing. Questions there? All right, next one I look at is number 42. Solve the inequality. X squared plus 10x plus 24. I want to know when this thing is greater than 0. You got to factor this thing. I think that's 6 and 4. Now the thing is, you can't simply say x plus 6 is greater than 0, and then x plus 4 is greater than 0. This is not correct, because the two terms are interacting with each other. And so what we have to do instead is we have to create a sign chart. On the sign chart, you put the two zeros. The 0 over here is negative 6. And the 0 over here is negative 4. And then simply ask yourself, inside each region, is the inequality sign true? So this first region right here contains numbers between negative infinity and negative 6, for example, negative 10. I simply plug in negative 10 into the equation, into the inequality, and I check to see if the inequality is true. Negative 4 times negative 6, is this greater than 0? 26 4 is 24. Is 24 greater than 0? Yes, it is. And so therefore I shade this region right here. Going to have an open circle because it's greater than. If it's greater than or equal to, I'll have a closed circle. Then the next region right here, I'll use a test point of negative 5. Because negative 5 is between negative 6 and negative 4. There are an infinite number of numbers between negative 6 and negative 4. So you can have lots of numbers to choose from. Again, though, I'm just checking, is the inequality sign true? Negative 5 plus 6. Negative 5 plus 4. That's going to be 1 times negative 1. That's negative 1. Is negative 1 greater than 0? No, it's not. And so if I don't shade that middle section right there. All right, the last section right here, I'm going to use 0. Because 0 indeed is greater than negative 4. I can choose any number between negative 4 and positive infinity. And so I just got to plug it in and make sure my answer, check to see my answer is greater than 0 or not. So 0 plus 6 times 0 plus 4 That's 24. And is 24 greater than 0? Because remember, that's the question. Is it greater than 0? The answer is yes, it is. And so again, I shade this region right here. So the answer to the question is that any number that's selected between -infinity and -6, or any number between -4 and infinity, will result in an answer that's greater than 0. And so that is it. Notice that it is not what this thing is saying up here. Questions there? Okay, you guys going quiet on me, huh? I know, I'm better keeping together my own stuff. Whenever a question says find the complex zeros, you must use the quadratic formula. Or complete the square. I'll use the quadratic formula. X is equals to -4 minus 4ac all over 2a. -4 plus or minus the square root 16 minus that should be 8. How about I say 16 minus 32. Square root of -16. And this is why you need to use the quadratic formula or complete the square, because at some point you're going to need to take the square root, and that square root is going to end up being a negative number. And that's where you get the I from. That's where you get the complex solutions from. That's going to be -4 plus or minus 4i over 2. That's -4 over 2 plus or minus 4 over 2i. -2 plus or minus 2i. And those will be your complex solutions. Questions there? Number 46. Absolute value x plus 8 minus 3 equals 11. You gotta get the absolute value by itself. And then when you drop the absolute value, you have to introduce a plus or minus on the other side of the equation. X plus 8 is 14. X plus 8 is -14. And so the answers would be -22 and 6. You can always check your answers. If you take them and you plug them in, you will see that indeed the inequality will hold. The equation will hold. For number 48, solve the inequality. What you do is you have to find the zeros. So you do what we did a while ago. You make it equal to, instead of a less than sign, 3k minus 4, add 6. Add 6 is equals to 3. You drop the absolute value, put plus or minus 3. You add 4, x. So 3k equals 7, k equals 7 over 3, and 4. Oh, I'm supposed to be adding 4. How about I say I shouldn't get negative 7. And that's gonna be 1. So k, goodness. I'm having a hard time focusing right now. Equals 1/3. And the rule is simple right here. If it's less than, you shade in the middle. If it's greater than, you shade on the outsides. So somewhere along this number line right here is 1/3 and 7 over 3. If it's less than, you shade in the middle. If it's greater than, you would shade on the outsides. And so the solution would be 1/3 to 7/3. If it was less than or equal to, you'd use square brackets because you would have had closed circles. Questions there? We already did this already for number 50. Finding the domain, you simply set the denominator not equal to 0. X cannot be -9. X cannot be 2. For number 51, to find the vertical asymptotes, it's the same thing. You take the denominator, but this time you set it equal to 0. I got to factor this. Again, the only difference, well, you have to also remember that you have to reduce the function before you find the vertical asymptotes. But this function doesn't reduce because there are no like factors in the numerator and in the denominator. 11 and 5. And so the vertical asymptotes are x equals -11, x equals 5. To find the horizontal asymptotes, or any question there? To find the horizontal asymptotes, you need to divide the leading terms. So divide these two right here. 7x squared divided by 4x squared. If it divides nicely, y equals 7 over 4, then that's your horizontal asymptote. If it doesn't divide nicely, then it depends on what you have. So for number 53, for example, y is going to, you divide them again, that's x over x squared. That leaves us 1 over x. When the denominator has more x's, the horizontal asymptote is going to be y equals 0. If it's the reverse and the leading term in the numerator has more x's, then the answer is none. There is no horizontal asymptote. So if this example happened to be x to the 4 plus 3 over x squared minus 49, when I attempt to divide it again, I get x squared over 1. This time, I do not have x's in the denominator because I had more x's in the numerator. When you have this, there is no horizontal asymptote. Okay, we're not doing oblique asymptotes, we're only doing horizontal asymptotes, and so therefore the answer none is fine. All right, so man. To solve an inequality like this one right here, you gotta set up a sign chart. This is a equals -6, a equals -1, and a equals 3. -6, -1, and 3. And then you just need to go ahead and check each section like we did earlier on. Plug in the number and then check to see if the inequality is true. If the inequality is true, you shade that region. If the inequality is false, then you don't shade that region. For example, over here, I can plug in 10 because 10 is between 3 and infinity. That's going to be 10 plus 6 times 10 plus 1 times 10 minus 3. Our question is that greater than 0? The answer is going to be yes. 16 times 11 times 7. I don't know what it is, but I know it's positive. And so that means I'm going to shade this region right here. I will let you do the rest, but you will see that you will also shade this region right here. Open circle, open circle. And so the answer will have two sets of parentheses. -6 to -1, union 3 to infinity. Those will be the areas where the graph is growing. Questions there? To find the composite function at a point, you simply take the number and you plug it in. And the answer you get, you take that answer and you plug it in to the next function in line. So you first have to find g of 4 out of 58. That's going to be 2 times 4 squared plus 1. 4 squared is 8. No, 4 squared is 16. 16 times 2 is 32. 32 plus 1 is 33. Sheesh, man, that's huge. I gotta take that and plug it into the second function. That's going to be 4 times 33 plus 2. 4 times 3 is 20, 120 plus 12, 132 plus 2, 134. Questions there? The graph was a one-to-one function. Sketch the inverse right here. To sketch the inverse, you just need to take the points and flip them. So 1, 4 becomes 4, 1. 0, 2 becomes 2, 0. 2, -1 becomes 1, -2. And -4, -2 becomes -2, -4. Trace them in the same connected pattern as they are in the original function. And that'll give us the graph of the inverse function. If you want to find the inverse of a function itself, you simply change f of x to y. Now, some people do this differently. Some people change the x and y now. Some people change it at the end. It doesn't matter. Obviously, you just got to change it at some point. Everywhere you see y, you write x. I'll just go ahead and change it now. Everywhere you see x, you write y. And literally, this is the actual inverse function. But it's just that we require you to solve for y. So I'm going to do that. X minus 5 is equal to 6y squared divided by 6 y squared is equal to x minus 5 over 6, and then you take the square root. Y is equal to square root of x minus 5 over 6. Now, remember the square root is plus or minus. Because this is greater than 0, i.e. taking numbers that are larger than positive, head trending in a positive direction, we take the plus sign. If it was the other way around, if it was x less than 0, then we would take the minus sign when I take the square root. Questions there? To graph the function, you just make a table of values. One-third to the -2. The negative sign means to take the reciprocal of 1/3, and then you square it. So that's going to be 9. That's going to be 3, 0, 1/3, 1, 9. When you plug each of those numbers in, those will be the answers that you can get. I'll leave it to the reader to verify. Number 66. ¼ remember a minus sign means a reciprocal, so that 1/4 to the -x is equal to 16. The minus sign says take the reciprocal of 4. So the two equations are now set. And I can rewrite 16 as 4 squared. Those will cancel. X is equal to 2. Therefore, -x equals to 2. Therefore, x equals -2. One second. All right. Let's try number 68. Oh, by the way, the answer 69 is 0, correct? Any number to the 0 power is 1, so x must be 0. 68. If I do a factor 3 and 32, 4 and 2, 2 and 2. That's 1, 2, 3, 4, 5 zeros. That's 2 to the 5th power. And 16 is going to be 2 to the 4th power. So this question is actually 2 to the 5th raised to 2x minus 5 is equals to 2 to the 4th multiplied by 3x. I replaced the 32 with 2 to the 5th. I replaced the 16 with 2 to the 4th. I simplified the powers. 5 times 2 is 10. 5 times 5 is 25. And 4 times 3 is 12. And now I've gotten base 2 on each side. I can cancel out the 2's. And so 10x minus 25 is equals to 12x. Subtract 10x on both sides. Negative 25 is equals to 2x. X is equals to negative 25 over 2. Jeez, man. Breathe. Questions then? All right. Change the exponential expression to equivalent one involving logarithms. The base is 6, so it's going to be log base 6. The log always gives us the exponent as the answer. And 216 is going to be your argument. Number 72, the reverse process. The base is 4. This is the exponent. And the argument is going to be on the other side of the equal sign. Remember, if you're having trouble converting to exponential form, you can simply drop the log and slide the base over. 1 over 16 is equals to 4 to the negative 2. That's a nice little technique to help you get to your answer. Questions there? All right. L and E cancel out. So 75, the answer is going to be 9. This is going to be log base 7 of 49 to the negative 1 power. Remember, we just talked about this. The negative power means the reciprocal. And it's going to be log base 7. 49 is 7 squared. That's going to be log base 7 of 7 to the negative 2. Again, just like number 75, log base 7 and 7 cancel out. And so the answer is just going to be negative 2. The last one, I'm out of space. I'm going to put it over here. Log base 7 of the square root of 7. That's going to be log base 7. Square root means that the power is 1/2. Remember, a radical is equivalent to a fractional power. If I had the 4th root of 7 to the 5th power, that's going to be 7 to the 5/4. If I had the square root of x cubed, that's going to be x to the 3/2 power, because there's an imaginary 2 right here. And that's how I got the 7 to the 1/2. And again, just like a while ago, these will cancel. And so the answer to this one is 1/2. Questions there? To graph a log, you convert to exponential form. Y is equals to log base 3 of x. Convert this to exponential form, it'll be 3 to the y power is equals to x. And what you do is you create a table of values. And this is one of those weird cases where you actually fill in the y values. So for example, if I plug in 2 for y, that's going to be 3 squared. That'll be 9. Plug in 1 for y. Plug in 0. Any number to the 0 power is 1. Plug in -1. The negative sign just means the reciprocal. Plug in -2. That's going to be the reciprocal of a third squared, and that's going to be 1/9. Again, if this was just your y equals 3 to the x power, the x and y's will just be flipped. Remember, inverse functions, all you're doing is just switching the x and y values. So now you gotta plot these very carefully. So at 1/9, it's -2. That's like right here. At 1/3, it's -1. At 1, it is 0. At 3, 1, 2, 3, it is 1. And at 9, 5, 6, 7, 8, 9, it is 2. And to the graph of the function will look like this. Questions there? All right, cool. Let's solve the equation. Whenever you have a log equation to solve, you convert it to exponential form. Drop the log, slide the base over. 4 to the x is equals to 64. 4 to the x is equals to 4 to the third power. Therefore, x equals 3. Number 79. Convert to exponential form, drop the log, slide the base over. X minus 1 is equals to 2 to the third power. X minus 1 is equals to 8. Add 1, x is equals to 9. Number 80. Again, convert to exponential form, drop the log, slide the base over. X squared is equals to 4/9. You take the square root. X is equal to plus or minus 2/3. But a base cannot be negative, so x is equals to 2/3 only. If we look back in your notes, you'll see that one of the restrictions on logarithmic functions is that your base cannot be negative. Okay. Number 81. This is going to be log base 2 of x to the 5. minus log base 2 of y to the 6th. Any term that's in the denominator is going to be negative. Any term that's in the numerator is going to be positive. And then we take care of the powers. That's going to be 5 log base 2 of x minus 6 log base 2 of y. Number 82, that's going to be log w of 7 plus log w of x minus log w of 5. The 5 is in the denominator, so it's a negative log. The 7 and the x are in the numerator, and so they are positive logs. Since 7 is being multiplied by x, multiplication splits into addition. And so that's why they're not together. Questions there? Number 83 and 84 is the same concept. This is positive and this is positive. So this is going to be log base c of 7 to the 6th power multiplied by 10 squared. I don't believe you need to work it out. Remember, the number out front right here is the exponent. Number 84 is going to be log a. This is positive and this is positive, so it's going to be q times p squared. And this is negative, so it goes to the denominator. Negative logs end up in the denominator. Positive logs end up in the numerator. Numerator. Questions there? Number 85. Log base 3 of x plus log base 3 of x minus 24 is equals to 4. You combine them, the plus sign becomes addition. Remember, we just did this a while ago. Plus sign becomes multiplication. So it's going to be log base 3 of x times x minus 24 is equals to 4. And just like we did in our earlier log equations, you convert this to exponential form. So you drop the log and you slide the base over. So x times x minus 24 is equals to 3 to the 4th power. So x squared minus 24x is going to be equals to 81. Yes, it's good to know your powers off the top of your head. X squared minus 24x minus 81 is equal to 0. I need two numbers. When I multiply them, I get 81. I want to add them, I get 24. Oh, 27 and 3. That's x minus 27, and then x plus 3. X equals 27. X equals negative 3. But we have to remember that logarithms have a strict domain. The logs of x, the domain is that x must be greater than 0. Logarithms don't take 0 as an answer, don't evaluate 0. Logarithms cannot be evaluated on a negative value, a negative number. And so, if I were to try to plug in negative 3, I would get a negative log. So therefore, negative 3 is not an answer. 27, on the other hand, results in a positive log, and so 27 is correct. And so this question actually only has one solution, and that solution is the number 27. Questions there? All right. Don't forget, systems of equations will be on test. Okay, use elimination methods to solve the systems of equation. First and foremost, remember it's a multiple choice exam, so you can simply plug in the X and Y values and see which ones work. It is true. Yes. The method of elimination requires that we cancel one of the variables. And so if I multiply the second equation by -6, if you look very carefully, the first equation remains unchanged. Is -66x, 6 times 3 minus 18y equals, what's 56 times 6? 6 is 36, 6 5. 336, and then you add the two equations together. These will cancel by creation. The reason why we multiply that number, so those two will be have opposite sides. So -64x is equals to plus 336 minus 112, 4, 2, 2. So that's 30, yeah, that's right. And so therefore, x is going to be 224 over 64. I can divide that by 2. So that's 112 over 32. And divide that by 2. So that's 100 divided by 2, 50. Total is 56 over 16. Divided by 2, 25, 28 over 8. And divide that by 2, 14 over 4. And divide by 2, 7 over 2. Sheesh, man. And so therefore, x is equals to 7 over 2. And since I now know that x is 7 over 2, I can plug it in and use that to help me find y. So 2 times, is it positive or negative 7 over 2? Oh man, I made a mistake. Multiply by -6. That's going to be negative. Oh man. And that's going to be -366. I'm going to add those numbers again. So that's going to be 8, 4, 4, negative. And I divide that. So x is equal to -448 over -64. And declare divide by 4. That's 1, 1, 2. 64 divided by 4 is 16. And divide by 2, that's 56. 6 8s are 56. Divide by 2. Yeah. No. 6 8s are 48. Divide by 2. So that's going to be 28 over 4 divided by 2. 14 over 2. 7 8s are 56. There we go. 7. So x is 7. And so now I know x is 7, I can plug it in. 2 multiplied by 7 plus 18 times y is equal to negative 112. 14 plus 18y is equal to negative 112. Subtract 14. 18y is equals to negative 126. And divide 126 by 8. And so y is equal to negative 126 over 8. I can divide by 2. That's 63 over 4. Really? -14, negative 112. I'm just double checking my work here. One, 2, 6. All right, cool. And so that's the answers for x and y right here. And that right here is the method of elimination. In the method of elimination, you multiply one of both rows. So you get that one of the variables will have the same coefficient. And then that will allow you to cancel them out. The method of substitution, on the other hand, is you take the first equation and you solve for one of the variables. In this case, right here, I'll solve for x. That tells me that x is equivalent to negative 2y plus 2. And then you substitute that into the other equation. So it's going to be 5, but instead of x, I write negative 2y plus 2 minus 9y minus 9. And now I only have y's in my equation. 5 times 2 is negative 10y. 5 times 2 is plus 10. Minus 9y equals negative 9. These two together give us negative 19y. Subtract 10 equals negative 19. So y equals 1. Yay. And if y equals 1, I can plug that in. X plus 2 times 1 equals 2. X plus 2 equals 2. X equals 0. So I have the answers 0 and 1. Again, what I was saying right here for systems of equations, because the multiple choice exam, if they're claiming that the answer choice is 0, 1, you just plug in 0 for x and 1 for y, 0 for x and 1 for y, and both equations should be correct. Graph the inequality 3x minus 4y is less than 12. You have to put in slope-intercept form. Subtract 3x. Negative 4y is less than or equal to negative 3x plus 12. Divide by negative 4. The inequality will flip. 3/4 x minus 3. The y-intercept is negative 3. And your slope is 3/4, so you go up 3, 1, 2, 1, 2, 3 over 4, 1, 2, 3, 4. And because it's greater or equal to, you draw a solid line. If it was just greater than, you draw a dashed line. Now it says that y is greater than. Greater than means above, right? If I'm greater than you, I'm above you. Numbers that are greater than 3 are numbers that are above 3. And so you have to shade above the line. If it was less than, then you'd shade below the line. Questions there? Again, remember, you can always, oh, look at the amount of time. For a system of inequalities, you draw both of them and you shade them both and see where they overlap. Or you can just simply plug numbers in the shaded region and the numbers should satisfy both equations at the same time. Anyways, x being greater than y means that y is less than x. And so that's going to be this line right here. And I am less than, so I'm going to shade below. I'll actually do the shading next at the end. And the other equation, 5x plus 6y is greater than or equal to 30. Take the 5x over, 6y is greater than or equal to negative 5x. Divided by 6. Y is greater than or equal to negative 5 over 6x plus 5. So this graph goes 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. And from here it goes down 5 and over 6. 1, 2, 3, 4, 5, right here. And again, this is going to be a solid line again. All right, y is equal to x. Y is equal to negative 5 over 6x plus 5. I'm less than for this one, so I'm shading down here. And then for this one right here, I am greater than, so I'm shading up here. And the final answer is going to be where the two shadings overlap. So the final answer is going to be right here. The final answer is going to be the shading where both things are true at the same time, i.e. where both things are shaded at the same time. All right, guys, I think I made it to the end. Whew, I barely made it though, but I made it. All right, feel free to send me an email. We made it, yay. The recording